This is page 2 of the review packet, chapter R. Let's start some factoring. The first problems, part A and part B. These, when I see this, I see a sum and I see cubes. So this is the sum of cubes. The sum of cubes, just something to know. You end up with a plus b times a squared minus ab plus b squared. You can figure this out with synthetic division or maybe some tools that we've done in the past, but this is what it comes down to every single time. On the right, it's very similar to the sum of cubes, but this is the difference of cubes. This comes out to be a minus b times a squared plus ab plus b squared. It's important, a couple of things here, to realize that these are all expressions, not equations. Expressions don't have an equals sign. You can't solve an expression. You can just factor it. Also, here, these are not going to be factorable anymore. It looks like something that we could sometimes factor, but in this case, we cannot. There are sort of contrived examples where you can continue to factor it, but those go beyond where we're going with this. The sum of cubes and the difference of cubes are two things that it really helps to remember. Now, I'm going to skip over to D, because D, this looks to me like a difference of cubes problem. If we can set this up to be some cube minus some other cube, that will make this a lot easier. For example, 64, that is 4 cubed. X to the 6th, well, that's really x squared and then cubed. Negative 27, that's minus 3 cubed. So what this problem's really telling us is we've got 4x squared quantity cubed minus 3 cubed. This is really no different than our a cubed minus b cubed, but now our a is 4x squared and our b is 3. So if I have a squared, I'm now doing times 4x squared quantity squared. AB is going to be plus 4x squared times 3, and b squared is plus 3 squared. I gotta simplify this a little bit to be 4x squared minus 3. Let's see, 4x squared squared is 16x to the 4th plus 4 times 3 is 12x squared plus 3 squared is 9. That is what we end up with here. It doesn't look like I can factor this anymore, so I'll leave it at that. Now let's go back to C. This looks like a tougher problem that I really want to deal with, but luckily I can factor some stuff out. For example, all of these are divisible by 2, and there's an x in every single one of them. If I do that, I'm left with 6x squared plus 10x minus 4. And now I've got smaller numbers and a quadratic instead of a cubic. So it comes down to factoring 6x squared plus 10x minus 4. I've got 2x, and I've got to put this into two linear terms. Here it gets kind of tough. For example, 6 could be 2 times 3. It could be 1 times 6. There's a lot of possibilities. Same thing with 4. So I know that I'm going to have an x and an x. And just to keep things... I see a mistake. This is not going to be 10x because I factored out a 2. This should be 5x. Slightly smaller numbers, a little bit easier to work with. Now, with these 6's, I think generally 2 times 3 multiplies together to be 6. And so I'm just going to try it. If I've got a 2x and a 3x, that gets me my 6x squared. And now the question is, what numbers do I have to put in over here and over there so that I multiply to 4 and I add to, or multiply to negative 4 and add to 5x? Well, here 2 times negative 4 gets me 8. Oh, negative 8. But I probably want it to be positive. So 2 times positive 4 gets me positive 8. And then the number that will have to go in here is minus 1. 8 minus 1 times 3 is minus 3. 8 minus 3 gets me that 5. This takes a lot of finagling. There's other strategies you can use, but it comes down to just sort of seeing the factors once you've done it so many times. So, let's go on to problem D. Oh, we did problem D. Let's go on to problem E. Problem E's got some crazy x to the 2/5 and x to the 1/5. That's not easy to deal with. Let's try making u equal to x to the 1/5. That way, instead of having negative 3x to the 1/5, I've got negative 3 times u minus 28. And x to the 2/5, well, that's just u squared. So I've got u squared minus 3u minus 28. Much easier to deal with than the 1/5 and the 2/5. This factors to be u minus 7 times u plus 4. And now it just comes back to making it x's again. X to the 1/5 minus 7 times x to the 1/5 minus 4. That is that problem. Last one, problem number F. I see I have 4 terms here. Luckily though, I can break it up into chunks of 2 terms and see what I can factor out here. For example, I can pull out a x to the 3rd from the first 2 terms, and I've got x minus 5. And I can pull out an 8 from the last 2 terms, and I have x minus 5. Oh look, I've got x minus 5 on both of these. What that means is I can factor out an x minus 5 from everything, and I'm left with, well, x cubed on the first one, and 8 on the second one. So, I see a lot of people say, look, I'm done, I factored. This is factoring by grouping. Hooray. But this is really only half done, because x cubed plus 8 is your sum of cubes. So, let's go back down and do our sum of cubes. X cubed plus 8 will be x plus 2, since 2 cubed is 8. X squared plus 2x, oh, not plus, minus 2x plus 2 squared is 4. And of course, I've still got an x minus 5 on there. So this is your answer. That is the second page of Chapter R review. I hope that you found it useful.